So here we are sitting with a Tamsin USA piston compressor. I guess first we need to discuss some of the things that would define this air compressor. This compressor is an electrically operated 7.5 horsepower, 230 volt single phase, 2-stage air compressor that's splash lubricated, mounted on an 80-gallon receiver tank. The air compressor is controlled off of a pressure switch, so when energized and pressure is less than the set point pressure, this will complete a circuit and supply control voltage to a coil that energizes the motor, connected with belts to the pump, and starts operating the compressor. When the high pressure and the pressure switch is reached, this contact is opened, control voltage is removed from the contactor, and power is no longer supplied to the motor, and the pump stops working. When the pump comes on, air is brought in to through these two air filters. Before we get too far, when we talk about stages and cylinders, there is a difference. It looks at the surface that we have 2 cylinders here, but we actually don't. We have 4 cylinders. So we have a low pressure cylinder and a high pressure cylinder on this side, as well as a low pressure cylinder and a high pressure cylinder on that side. Air comes into the low pressure cylinders only. So we have 2 low pressure cylinders, and a real easy check is to count air filters. Most of the time, every low pressure cylinder is going to have its own air filter. So it's a real quick and simple way to know how many low pressure cylinders there are. So air comes in through these air filters, and there's valve blocks on the top of the heads. They're all controlled by suction, so some are under the plate and some are over the plate. So when the piston comes down in the cylinder, it forces the inlet valve open at the same time it's closing off the discharge valve. So air is drawn in to the low pressure sides and it is compressed. It then discharges out the low pressure cylinder out the other side, and it runs through an intercooler. The intercooler is meant to reject some of the heat of compression before getting into the second stage. There are blades on the back of the sheave, the pulley. There are blades that are drawing air across the piston compressor, and the fins on this intercooler are aiding in rejecting the heat of compression from the piston. Now, after it goes through that intercooler, it circles around and goes to the suction side of the high pressure cylinder, the second stage. It is compressed again, it is compressed higher, and then it discharges out the backside of the high pressure cylinders on both sides, and now it's going to come through to a receiver tank. Now when we come through to the receiver tank, we go through a tank check valve first. The reason we have to go to a tank check valve is because when the compressor shuts down and it goes to restart, if the pressure of the receiver tank is on the pump, the motor will not be able to overcome that and start. So we then go into the receiver tank, and then we would go out to the process here. When the compressor does turn off, the air from the heads is vented through this 1/4-inch line right here. So the pressure switch is opening, it's taking voltage off of the coil, and then it's also venting the heads through this line. And that is the basis for how a piston compressor runs.